Okay, guys, 13.3 part 2. We're still talking about geometric, but today I'm going to do one extra problem. This is on your web assign. And I also want to do your infinite and finite geometric sums. You'll see that in a second. There's two formulas for it. So if you know that you have a geometric rule, all right, we did a question like this. There was one on the quiz. There was a bunch in the notes where you're given two terms. They're not right next to each other. So you have to figure out all the information to write the rule. So think about a geometric. You have a sub n equals. You have to have the first term. You have to have the common ratio, right? We have to find those two things. A lot of times you're given one of those things by given the sequence, that sort of thing. In this case, we're not. Now, since this is geometric, I cannot say that this point is 3, negative 4/3, and this point is 7, negative 64 over 243, and find the slope. The reason why we can't do that is because this is not a linear function. All right, those are 2 points that are on this graph, absolutely, but this is not going to be something that's added or subtracted every time. You can't find the slope. So we're going to use this formula 2 times with the information that they gave us. All right, we're going to first find the common ratio. Then we're going to find the first term. So we're going to take this information that they gave us and we're going to plug it into the formula. So I'm going to say the one that's furthest away, and you'll see why we did this in a second. A sub 7 equals A sub 3 times R to the n minus 1. And the reason that you put the furthest one away is because when you subtract the terms, you have to figure out how far away they are from each other. This is what this is going to figure out. This is going to figure out how far away the terms are from each other. So you have to have 7 minus 3 versus 3 minus 7. Everybody see we're just using the formula. So now let's plug in. What is the seventh term? Well, it's negative 64 over 243 equals, what is the third term? Negative 4 over 3, correct? And then the last thing we're going to say is our R to the, we're going to subtract the term numbers. We're figuring out how far away these terms are from each other. So just say to the 7 minus 3 power. We're figuring out right now how far. This is what this is going to tell us. So if we simplify this, negative 64 over 243 equals negative 4 over 3, R to the what? Fourth power. It's 4 spaces away. So if I'm going to solve for R, guys, how do I get rid of that negative 4/3? We're going to multiply both sides by the reciprocal, right? Everybody with me? Okay, so what happens with 4/3 and negative 3? They cancel. So you have R to the 4th power equals, can I simplify anything here? Well, 2 negatives are going to give me a what? A positive, good. 4 goes into 4 one time. 4 goes into 64 how many times? Guys, calculator, 64 divided by 4 is what? 16, okay. And then 3 goes into 3 one time. How many times does 3 go into 243? 81, okay, that's good. So you have 16 over 81. Now, I don't want to know what R to the 4th power is. I want to know what R to the 1st power is. So what would I do? I'm going to take the 4th root of each side, right? Agreed? Okay, so I say, what number of times itself 4 times gives me 16? No. 4 squared is 16. What number of times itself 4 times gives me 16? 2. What number of times itself 4 times gives me 81? 3. So your R value is 3. Now, some of you might pick up on that and say, well, wait, since it's a 4th root, square root, 4th root, 6th root, you'd put plus or minus in front of your answer. The reason why we're not is in the directions, it should have said here, assume all terms are positive in the sequence. Why would that matter? How is the only way that you could go from a positive to a negative, from a positive to a negative? What would your R value have to be? A negative number. So since they'll tell you if it doesn't alternate back and forth, if they say assume all are positive, what that means is if you take an even number root, this is what they want you to just have, just the positive. So you guys now know what R equals. So now we're going to go back to how we figured out the first term when we had an arithmetic. I'm going to use the same formula. A sub n equals a sub 1 times r to the n minus 1. I can use either one that they gave me. They gave me the third term and they gave me the seventh term. I'm going to use the third because the number's smaller. So the third term they gave me was negative 4/3, right? Equals, I don't know what the first term is, but I do know what my r value is. What is it? 2/3, good. And negative 4/3 is what term number? 3. So I'm going to put the 3 here, so it's 3 minus 1. And then now we just simplify. So I have negative 4/3 equals a sub 1. What is 3 minus 1? 2. So this is squared. Where does that squared go? To just what? Or both? It goes to the 2, and it goes where? To the 3. So 2 squared is 4. 3 squared is 9. Correct? All right, so I'm still trying to get a by itself. How do I get rid of 4 over 3? Sorry, just kidding. How do I get rid of 4 over 9? Multiply by 9 over 4 on both sides. So those cancel. So now you're going to figure out your first term is, well, can I simplify anything? Yep, 4 goes into 4 once. 4 goes into negative 4, negative 1, right? What about 9 and 3? This becomes a 3. This is a 1. So your first term is negative 3. So now do we have enough information to write the rule? Yes. So your rule is going to be a sub n equals the first term, which is negative 3, times r, which is our 2/3, raised to the n minus 1 power. That is the rule. When they say write the rule for the nth term or something like that, there's your rule. The second part of this question asks you for the 12th term. Now, guys, you need to be careful here. In these problems, we have all fractions. Do you see any decimals here at all? No. So your answer should be in a what? Fraction. So when you throw this in your calculator and you get a decimal answer, you have to go through and simplify throughout so you don't get a decimal. Meaning, I'm going to have negative 3, and then I have 2 over 3. What term number am I finding? The 12th. So this is going to be to the 12 minus 1. Everybody with me? Okay. So now we simplify. I have negative 3, and then 2 over 3 to the 11th power. Now what do I do with that 11? It goes here, and it goes here. So don't just put everything in your calculator and get a big crazy number. Go step by step. Negative 3 is on the outside. Guys, what is 2 to the 11th power? 2048? Okay. And then what is 3 to the 11th power? 177? 147? Okay, good. Now, again, big gross numbers, no big deal. Let's simplify a little more. Just try. Does 177, 147 divide evenly by 3? What does it become? So this is 2048 over, and it's going to be negative, right? What does it become? 049? Okay. Now, can you simplify that anymore? Put it in your calculator. If it does not simplify anymore, nice and pretty, anything like that, then you're done. But notice, guys, no decimals are in here. Don't put that in your calculator and give me some crazy looking decimal answer. If you start off in fractions, with a lot of the geometrics will, that's what you'll end up with. So just take your time. Do each step separately. That way you don't get confused. You don't get stuck anywhere. Questions? All right, so now we're going to talk about two formulas and two different kinds of sequences. When we talked about an arithmetic sum, there was just one. We had that formula, right? The S sub n equals n over 2 times a1 plus a sub n. This is for arithmetic. You guys will be given that on the test. There's two kinds of geometric sequences. One is called infinite and one is called finite. What is the difference between those two words? One never ends and one does end. Okay, good. So you're going to have two different formulas. I'm going to show you how to use each of the formulas, but I want you to understand what is involved in each of these for a second. You'll understand why it has an ending and stuff like this, but this is for a finite. What does the word finite mean? Has an end point. Finite has an end. It ends. If you have an infinite, you'll either have a dot, dot, dot at the end, or you have the infinity sign. I'll show you in a second. Now, we have to figure out some things in this formula. What are the things we have to figure out before we plug it in? What is a sub 1? The first term. Good. What is your R value? It's your common what? The common ratio. Good. And what is n? It's the number of terms. How did we figure out the number of terms? What was that tiny little thing I told you to remember? If you're given like that funny looking E, how do you figure out the number of terms? Top minus bottom plus 1. All right, so we're going to use that. Take a picture of this if you need to and put it next to each of our problems. All right, so if I want to find the partial sum of a geometric sequence that has an ending, you guys will understand why it has an ending. So let me go to this first example here. All right, it says find the following partial sum of the geometric sequence. There's 7 terms in the sequence. Looking at this, how do I know that this has an ending? Does this go like this? Dot, 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 meaning it's going on forever? No. They tell you the beginning, they tell you the ending. Okay, that's good. So let's figure out the information that we have and the information that we need. So my formula, I'll do it over here. The sum of this is a sub 1. You can just put it in the numerator. R over 1 minus R, correct? So there's a bunch of stuff that we can just look at this and see exactly what we need. What is your a sub 1? What is the first term? 1. Good. What is your R value? How did you get from 1 to the next? Times 4. How can you figure that out? What did I tell you guys to do? Take one term and do what? Divide it by the one in front of it. So 16 divided by 4 is 4. So your R value is 4. The last piece of information you need is how many terms are in this sequence. What were you told? No. How many terms? There's 7. So your n value is 7. In your arithmetic, you need what the end term is. You don't need to know that in this one. So now we just plug this in. Now, guys, this is a very basic computational problem that you have to do step by step. When I plug this in, I have a sub 1 is my first term, so I have 1. Then in parentheses, I have 1 minus, what is your R value? 4 to the what power? 7th power. And then on the bottom, 1 minus R, so 1 minus 4. Everybody agree? Yeah. All right, so now your numbers get big. Do not try and do everything at one time. Some of you are going to say 1 minus 4 is negative 3 and then raise it to the 7th power. Is that the correct way to do this? No. What do you do first? 4 to the 7th power. So I have 1 minus, what is 4 to the 7th power? 16384. Perfect. Over, what is 1 minus 4? Negative 3. Signs matter. Be careful. So now let's keep simplifying. What is 1 minus 16,384? Negative, what is it? 16,383. All right, divided by a negative 3. Well, right away, I know that a negative divided by a negative is a positive. Good. So go ahead, do that in your calculator. If it works out to a nice, pretty number, you're good to go. If it doesn't, we're going to have to leave it as a fraction. What is the decimal? Oh, so it repeats? No. Okay, so if it does not simplify, right? 16,383 divided by 3. What does it give you guys? Tell me. 5461.3333333. Is that what you guys got or no? Okay, so do it in your calculator again. That's what I thought. Negative 16,383. 5,461. There's your sum. Now, if it doesn't say no decimals or anything like that, then you guys can use a decimal. If it says fractions only, fine. If it says terminating decimals only, that means only ones that don't repeat in your calculator. Just read the directions. But do you guys understand the process?
It just says 7. It's just going to say that on the test.
No, sometimes it'll look like this. Right? First of all, if I didn't tell you, if I just said find the sum, you guys are going to be like, wait, I don't know. How do I figure out which formula to use? First of all, decide, is this arithmetic or is this geometric? Arithmetic, you're going to add or subtract the same thing every time, yeah? And in geometric, you're going to multiply. What's another thing you can look at this and be like, oh, it's definitely geometric? What do you see? You see an exponent. Perfect. When you see an exponent, you're like, oh, this has to be an exponential. This has to be geometric. So now you look and you say, well, how do I know if it's infinite or finite? Well, think about this, guys. What is this telling us? It's telling you to start plugging in what? 5, and stop when you plug in 12. So is there a beginning and an ending? Yes. So think about what we need for the formula. You need to know how many numbers you're dealing with. You need to know the first term, and you need to know the R. We can tell all that, guys, by the information they gave us. How many numbers are we dealing with here? How do you figure it out? 12 minus 5. Top minus bottom. Good. Plus 1. Okay, so 12 minus 5 is 7 plus 1 is 8. So your end value is 8, okay? What is the first term? How do you figure out what that first term is? It's not 5. What do you have to do with the 5? You got to plug it in. So I'm going to say, okay, start plugging in. So I have 2 times 3 to the 5th power. What are you going to do first? 3 to the 5th, which is what? 243. All right, times 2? 486. Everybody with me? And then R. What is your R value in this? You can just look right at it. What is your R value? It's right in here.
Oh, 2 times.
What is your R value?
3.
Just 3. It's whatever's with the exponent. So now we can plug everything in. So your formula is the first term. Well, we found out the first term was 486. Then I have 1 minus R. Whoops. R is 3, right? To the what power? Ooh, to the 8th power. This is going to get big. It's okay. It's totally fine. And I'm going to divide that by what goes in my denominator? 1 minus R. So 1 minus 3. Perfect. Now again, guys, please do not throw all of that in your calculator. Let's simplify step by step. I have 486. Whoops. What's going to go inside my parentheses? Am I going to say 1 minus 3 and then raise to the 8th, or what? Good. You're gonna raise 3 to the 8th power first. So it's 1 minus, tell me again, Faith. 6561. Okay. Divided by, what's 1 minus 3? -2. There you go. All right, I'm going to bring it down here. So still, 486 out front. You guys are good? What is 1 minus 6561? -6560. Okay. All over -2. And now this just becomes a calculator problem. First of all, I see 2 negatives, so I know my answer is going to be what? Okay, positive. What's 486 times -6560? 160. Okay, divided by -2. So a negative divided by negative, like we just said, is going to be a positive. So guys, in your calculator, what's -3,188,160 divided by -2? What do I get? 1,594,080. So when you start plugging in 5 and you stop plugging in 12 into that expression, and then you add it all together, that is the sum of all those numbers. Does that make sense? It's not a difficult process. You just have to understand what you're looking at. The next one's even easier, the next formula. Let's do one more. This one, I want to do this one because it has a fraction. So again, think about the things we need. We need to know how many terms we're talking about. We need to know what the first term is, and we need to know what our common ratio is. How do you find out how many terms we're dealing with? 18 minus 2 plus 1 gives me 17, right? 17 terms. That's number n, that's n. So then A1, how do I figure out what the first term is? Plug in 2. This is telling me to start off with 2. So I have 8 times 1/2 to the 2 minus 1 power. So think about this, guys. What is 2 minus 1? Just 1, right? So you just have 1/2 to the first power. So what is 8 times 1/2? Just 4. Good. And then what is your common ratio here? 1/2. Good. All right, we're going to have to deal with fractions. That's okay. So let's plug it in our formula. My first term you said was 4 times 1 minus our R value, which is 1/2. And we're going to raise that to what power? Ooh, 17. Oh, n minus, just to the n, you're right. No, 17. The formula in your formula is just n, the number of terms. All over, what do we put that over? 1 minus our R value, correct? All right, there's a lot going on in this problem, so let's just take it step by step. My 4 is still out in front. 1 minus, where does that 17 go? To the 1 and to the 2. So this is 1 over, guys, what's 2 to the 17th power? 131072. Okay. All over what? What's 1 minus 1/2? Well, I can rewrite 1 as 2 over 2, can I? So 2 minus 2 minus 2 over 2 minus 1 over 2 is just 1/2. Okay, good. All right, again, we're dealing with fractions. That's okay. Don't put this in your calculator as 1 minus this fraction. It's going to give you a tiny, crazy decimal. I want you guys to think. I want you to think. If I'm going to subtract fractions, they have to have a common what? What's a common denominator between 101,072 and 1?
I have a question.
Hmm?
When the 1 to the power of 17 wouldn't be -1, so does that turn into 1 plus the fraction, or it just says
The negative, the 1/2 that you're raising to 17th power is positive. The negative's on the outside. Good question. But guys, what would a common denominator between these two be? 131072, right? So this, I could rewrite this as 131072 over 131072. Don't you guys agree? So all this ends up being is 131072 minus 1. It's 131071 over 131072. That's always going to happen because it's always 1 minus. Your common denominator is going to be whatever that big thing is, and then you just simplify. So that's divided by 1/2. All right, there's still a lot going on here. See what you can simplify first. Does 4 go into this number? Lots of times it does. What's 131072 divided by 4? 32768. Okay, so I have 131071 over, this canceled and this became that, and then I still divided by 1/2. Now again, you do this in your calculator, you're going to get a crazy decimal. Guys, if I had 1/2 divided by 1/3, you would tell me, oh, you keep changing flip. Just because you have big numbers doesn't mean anything. How do you divide fractions? You keep 131071 over 32768, right? Change, and then what do? I flip. I'm going to multiply by 2 over 1. Now, if you notice, this number is even, is it not? I bet 2 goes into it. 16384, and then my numerator is 131071. Now, if you did any of that in your calculator, you would get a ridiculously tiny decimal. That's not what we're looking for. Questions? That's the hardest kind of problem you're going to do. And why is that hard? Because you're dealing with fractions. There's nothing in here that you guys can't grasp the concept. It's just taking your time, simplifying step by step, You guys will be fine. Questions? Yes. Yes, yes, yes. All right, next one. Whoops. We're going to talk about an infinite series. This is easier. What does infinite mean? It never ends. Infinite never ends. Infinite never ends. How can you tell if something is never ending? There's two ways. If they list the numbers out, do you notice this dot, dot, dot? What does that mean in English when you say dot, dot, dot? It keeps what? Going. If they have it written in summation notation, right? The bottom is a starting point. The top is the what? Ending point. They're going to have an infinity sign on top. That's how you know it's infinite. Does that make sense? Okay. Also, if you are going to have to decide between, do I use geometric or do I use arithmetic? Did we do anything with arithmetic where it talked about infinity? No, so you don't have to worry about that. Now, here is the formula for an infinite, one that never ends. Does this one look a little easier? Yeah, all you need to know is the first term and the common ratio. That's it. You're not going to have to raise things to some ridiculously huge power or anything like that. It's just first term over 1 minus r. So let's do a couple of examples, and then we are finished. All right, now, this is not written in summation notation. This is just written in the sequence order. They're telling you a lot of information just by looking at this. First of all, they're telling you that this does what? It doesn't end. This is an infinite. So right away, I know it's geometric because we didn't talk about infinite with our arithmetic. So think about what you need. You need two things. You have to have the first term and the common ratio. Do you know the first term? It is 2. How do you know that? Look at it. Now, how would we figure out the common ratio? Take one of the terms. I'm going to take 2 over 25. And do what? Divide it by the one in front of it. So 2 over 5. Guys, we're dividing fractions. How do you divide fractions? You keep, change, flip. Simplify this. What happens to the 2's? They cancel. 5 goes into 25 how many times? What's your common ratio? 1 over 5, 1/5. So this becomes 1 minus 1/5. Now we have some basic math we got to do here. Yes, you have a calculator, but this is in fractions, so I want it to stay in fractions. What's another way I could write 1 as fifths? Can I replace this as 5 over 5? Okay, perfect. So let's simplify. I have 2 over, what's 5 over 5 minus 1 over 5? 4 over 5. Now, is that a complete answer? No. Right, this is 2 over 1 divided by 4/5. So if we keep change flip, it's 2 over 1 times what? 5 over 4. And then we simplify. 2 goes into 2 once. 2 goes into 5 twice. So the sum here is 5 over 2. You, on the infinite one, you are not going to get a huge, ginormous number. Because all you're dealing with is the common ratio in the first term. So 2 more and we're done. Done, done, done. Let's look at this. Think about what we need. We need the first term and we need the common ratio. You guys can look at this right now and tell me what the common ratio is. 7. How do you know this is geometric? 2 ways, just by looking at it. 2 ways. There's a what? There's an exponent. Good. And what's another thing that hints you to that? Infinite. So you know it's an infinite. It's a infinite, meaning it goes on forever. So how do you find the first term with the information they gave us? You're going to plug in 4. So I have negative 2 times 7 to the 4th power. What does that equal? 7 to the 4th power first, then times by negative 2.
It's 90. Negative 90.
7 to the 4th power?
Oh, 7 to the 4th power.
Yeah, do that first. And then times by negative 2.
4/18.
4802. Okay, we need that. We need that. So my formula says take the first term, negative 4082, and divide it by what?
4802.
4802? All right, sorry. Thank you. 4802. All right. I wrote an 8. Woo, this one's hard. What goes on the bottom? 1 minus what? 1 minus 7. 1 minus 7. 1 minus r. So now just simplify, guys. What's 1 minus 7? 6. So negative 4802 divided by negative 6. Well, right away, I know a negative divided by a negative is going to give me a positive, okay? And then what's negative 4802 divided by negative 6? Do I get something pretty? No. So since I don't get anything pretty, I'm just going to simplify. Like you just told me, a negative divided by negative is a positive. Perfect. What number goes into both 6 and 4802? 2. So what's 4802 divided by 2? 2401? Okay, so 2401 divided by 3. There you go. Perfect. One more. I need to know the first term and the common ratio. What do I know just by looking at it? Negative 2 is your common ratio. Perfect. How do I figure out what the first term is? Plug in 3. So I have 2/3 times negative 2 to the 3 minus 1. So think about what this is saying. It's saying 2/3 times negative 2 to the second power, right? What's negative 2 to the second power? Positive 4. So when I multiply these together, what's 2/3 times 4? 8/3. So there's what we need. My common ratio and my first term. So I take the first term, which is 8/3, divided by 1 minus my common ratio. So 8/3 divided by, what's 1 minus a negative 2? 3, right, over 1. If we have a fraction divided by a fraction, we keep, change, and then what? Flip. So my answer is 8/9. Everybody agree? Okay. And that, ladies and gents, is it. So you have everything you need now. You should have 3/4 of your web assign done. So now you just have to finish these ones. If you didn't start it until now, you have a long web assign assignment for tonight. And then tomorrow in class, we have a shortened class period. We're going to do Pascal's triangle.